Okay? So with this, we have a good legacy, but we need to continue. But we need to continue the great product performance for the future. And how we are going to do it? As we know, a robust process development and a better product will continue the legacy for us. And if we take a look, how is the perspective from a customer, where customer need a certain requirement, at the same time we have on the other end the process development. By matching the metrics and understand the customer requirement, we will need to focus on the right sector, which means we must develop.
We must develop
the right process to fulfill the customer need, which again is falling into this sector. And how to develop a good process? First, everyone know customer come with a requirement. This is a top-down process. Do we have a choice? Most of the times, we don't, because this is defined by the customer over here. However, we have a choice. We have a choice in what? We have a choice to select the right material, to develop the right process. In a way, we will be able to make the process to be so robust, which all the times the material and the process will fall within the requirement
of our customer
with the right process capability. By doing so, component by component, process by process, it will start from the lower level, go to the next subs level, and subsequently go to the end product. And what we are going to achieve will be something like this, whereas the red line indicate the spec, and our process is so much focused within the process. So with this, our performance will definitely be much better than the customer expectation. Okay? And to do this, we already have all the equipment that are required. Not to mention all of them, but those are the equipment that we already put in place. By putting this in place, we need all of you to start using this equipment to ensure we have a good process. And these are the level of the process development or the material development that we can continue to improve. Okay, first will be the material and the process control. Have you heard about people always say, listen to your customer?
Yeah, always.
Yes. Have you listened to your process or not?
No.
No. Yes. Okay. So one of it is when we establish the SPC to monitor our process. That is the voice of our process. When the process is moving in the wrong direction, we need to understand that and make sure we took the right improvement to bring them back to the target. So with this, we will be able to control our material and our process over here. In terms of the epoxy, we use a lot of epoxy, and a lot of this epoxy need to be mixed within the plant. How to actually make sure that epoxy is being traced in a proper way. So that is part of the process control. Again, other critical material Teflon component like the hybrid, all need to have a traceability. Lot to lot variation, batch to batch performance different will be properly tracked. And these are one of the examples that we already did in the past. How we do it is, after we mix the epoxy, it will come to a station where we are going to put the code for the individual epoxy. So epoxy A will be labeled A, epoxy B will be labeled B, and there is not a requirement for the operator to actually look for other information. They just pick the right epoxy, they can use it immediately on the production floor.
Right.
Okay? Next, after the material control, what will be the next level of the process that we can do? Which is process improvement.
Okay.
So the improvement can come from many angles, and one of them is getting the improvement on the material. Utilize it at a higher level. Instead of this, we are going to actually increase the utilization of the material.
Good.
The other thing will be how we can actually eliminate certain processes to make it more robust over here. Okay, if you take a look on this material, we think that the number of the quantity that we produce is good as of today. We cover quite a lot of the area to punch out the hole. However, if you look further, there's so much of opportunity that we can continue to improve. And by changing the program, today you can see that we already made an improvement of 47% in terms of material utilization on the big tube, and 80%, around 80% for the small tube. And how much is going to save us? It saved us more than 20,000
per annum.
Okay, yes. So this is a small activity on the improvement, but continue to create a good saving on the material. How the saving on the material help us? It reduce the product cost. Okay. Next will be the improvement that come along the process. Instead of having it to be reflow on the hybrid, now we can actually make a change on the process. We introduce the welding of the wire to the hybrid. By doing so, we are seeing that the reject rate is coming down, not a little, but it was significantly eliminated in terms of the reject rate. And with this, another saving, significant saving, from averaging about 2%, it actually come to almost zero in terms of the reject rate here.
Okay.
After the improvement,
and the value of that improvement was?
I can't recall, but it was quite significant. It could be 30 over 1,000
per annum.
Yes.
Okay.
So after the material control, material improvement, what next we can do? We need to optimize the process as well as the material. How to make the optimization over here?
Control, improve, optimize.
So there are a lot of the opportunity. One of the example is making the component getting lesser and lesser. Process step is reducing, and the cost will continue to come down. And these are the example. Today, if you take a look on this picture, we are having the tube as one component, the plate as the second component.
Yes, two components.
Yes. Can we think about a way to do it? Yes, if you put an effort on it. And how to do it? Let's look at this. The tube is combined with the plate. And with this, definitely it helps in many aspects over here. reduce the component, reduce the process step,
Yes.
and improving the yield.
Yes,
Okay.
of course.
After this, what else we can do further? We can actually think out of the box. And this out of the box is something people call it as a transformation. Some other people call it as an innovation. Regardless of the word, it will show you the impact on this. Today, this is already a history. We no longer use this particular process. But in the past, if we took a look, all these are the head producing the component. What are the component? The diaphragm that was individually produced. When they make from many head, one to the others, there will be a variation in terms of the performance.
Of course.
So by looking into this, we managed to come out with the improvement that will transform it to be a very consistent component, and eventually it brought us to a material saving and also process capability, which is 4 times better. With this better process capability, it means we are going to reduce the testing of this component. Reducing the testing, it will reduce the cost for the operator.
Okay.
So that actually helps us. So again, I would like to emphasize one more time, getting the right process to deliver the right product is very important. It has been proven in the past, and if we continue to go along this, I am very sure this is going to help us, not only one, in terms of the manufacturing cost during mass production, it will also help us during the improvement iteration, as well as faster MPI launching. So with this, I urge all of you to stay focused and move along this for a better future.
No, not quite.
Okay.
Not quite. Repeat the call to action. You must the call to action must have the phrase process improvement in it.
Okay. One more time.
Try.
Yeah.
Therefore, no, your call to action just now did not have the phrase process improvement in it.
Okay.
So your call to action must have that phrase. So one more time.
One more time is
Therefore,
I
urge
every one of you to continue stay focused along the process improvement to make a more robust process and a better product that will ensure we are ahead of the competition.
Thank you very much.
I would like to say thank you.
Well done.
Okay.